Hello. Yes. Let's start. Very good morning to one and all passionate technocrats present over here for our IEEE sponsored FDP on blooming research areas under IoT, a 360-degree view. So we have an eminent guest today with us, Mr. Bhanwar Bishnoi. I heartily welcome you, sir, in this session.
Thank you. Thank you for
Yes, sir. Yes, sir. It's a pleasure to introduce our today's respected expert speaker, Bhavalal Bishnoi, sir. Bhavalal Bishnoi, sir, is the head of Department Embedded Design and Development Center (EDDC) for Schneider Electric, erstwhile L&T Electrical and Automation in Mumbai, India. He is the chairperson of IEEE Bombay section in Power and Energy Society. He has 26 years of core R&D experience in electrical electronics industry. He is postgraduate MTech Embedded System from BITS Pilani and Executive MBA from IIM Lucknow. He holds postgraduate certificate GE sponsored 1 year program in reliability and testing engineering from University of Arizona, USA, and holds a bachelor degree in electronics and communication engineering from India Government College of Engineering, Jodhpur, which is established in 1951. He holds 40 plus patents in the areas of LV switchgear protection and metering relays and relays design and numerous papers and publications in leading global magazines. Mr. B. L. Bishnoi sir is the chair of IEEE Bombay section PES IAS joint chapter and ex-com member as well as senior member of IEEE SMI IEEE since April 2015. IEEE member since 2007 and has received GE Energy Industrial Solutions GE Management Award in 2009 by Krish Fulistier GM, G Industrial System USA. Bishnoi sir is GE certified Six Sigma Green Belt as well as GE certified reliability practitioner and expert. Bishnoi sir has started his career with Secure Meters Limited, Udaipur in 1997 through campus placement as GET and has had manifold work assignment in the electronic energy metering including grid metering, most complex product as Apex, prepayment energy meters, design ultra-high magnetic immune and meters, tri-vector meters, single phase meters, smart energy meters, etc. He has worked with General Electric USA for around 10 years, in L&T for 8 years, Landis plus GYR Limited Toshiba Group Company for around 2.5 years, and in Schneider Electric for 3 years. He is pursuing his PhD. He is pursuing his PhD, where 65% completed pending thesis submission and defense. So it's a great pleasure to meet you, respected Bishnoi sir. Please give your insightful technical sides to us, our participants. Thank you, sir.
sure. Thank you. Thank you
We
very
heartily
much.
welcome you, sir. Yes, sir.
Yeah. Thank you very much, Mr. Vijay Chaudhary.
Yes,
And
sir. Thank you.
I think it's a pleasure to be with all the academician. I am from industry basically. So
Yes, sir.
I had never worked in academics, but I studied in academics. So that's my academic background. So it's a pleasure to be with all of you, and maybe I will share my presentation. Just give me. Yeah. So I will open my screen. Just hope it is visible now. Hello.
Yes, sir, it is visible.
Okay, sure. Thank you. Thank you for acknowledgement. So this, I think today's topic is the business model or the smart factory, basically IoT business model or smart factory, because smart factory is one of the case study or example of IoT implementation to monetize the the concept of IoT. So that is, I think, the beginning of this talk. And in this talk, I will be covering the Industry 4.0 because the smart factory is again function of the Industry 4.0 because that is the backbone of this. And with that, I think I will this is, I think, the today's program and sponsorship. So thanks, St. Francis Institute of Technology, Mumbai, for organizing and hosting this event. So if I see smart industry 4.0 or smart industry or smart factory, whatever we call as, so it has a like kind of feature which is like industry 1.0, 2.0, 3.0, 4.0, and now even we are thinking of industry 5.0. So that is like already post 5G or 6G implementation, that also is going to come in. So if I see the fourth industrial revolution, how it took place, and the first industrial revolution, if you see mechanization, which was steam and water power. So if you see James Watt, when he designed or when he released the steam engine, so that was like kind of mechanization which took place. Second industrial revolution was electrification, which is about the mass production and conveyor kind of concept. So if you see like here, Ford Motors, they had implemented assembly line for cars as a electrification, and that was part of industry 2. I mean the industrial revolution 2 or industry 2.0, where they had offered their workers like they can work for 5 days a week instead of 6 days a week. So that was the outcome where all the stakeholders were in happy mode, where employees are also happy, the productivity was also higher, and the industrial revolution 2 has really contributed to mass production and conveyor belt concept, and that has changed the industry to the next league. The third industrial revolution was more about automation, PLCs, computers, CAD CAM kind of scenario, where it has helped the industry to take a leapfrog jump in the productivity with the maybe lesser resources, and hence the output has increased drastically. The fourth industrial revolution is like digitization, where cyber physical systems, IoT, IOP, or AI and 3D, so those are in place, and data is playing a key role. So that's where I think these are the snapshot of the industrial revolution which has took place. And maybe in the subsequent part of my presentation, I will take you through the smart factory visit also, a virtual visit. So like how in reality the smart factory really works, and what are the ingredients required, as well as what is the learning opportunity for the employees, what is the customer benefits, and then what is the kind of design concepts which is there. So you might have heard about the industrial design, as well as the kind of product which is being designed, and which is being offered to the customer with the kind of Six Sigma quality. So industry 4.0, basically Germany has took a quite leap, or maybe even leadership coalition with USA. So collective term of technology and concept of value chain organization based on the technological concept of cyber physical systems, the Internet of Things, and the Internet of Services, which is called as IoT and iOS. It facilitates the vision of the smart factory. So if you see, the backbone of smart factory is the IoT basically. And within the modular structure, smart factories of industry 4.0, cyber physical systems monitor physical processes, create a virtual copy of physical world, and makes decentralized decisions. So the key is here also the decisions are taken close to the edge or the node actually. Whereas the data accumulation and the data analytics for longer term perspective to enhance the productivity, customer experience, they are done at the centralized level also. Because why you need to take a decision near the edge or node? Because you can have a faster response time, you have low latency, while data's long-term perspective, you have a data in the cloud where you can run the analytics and you can have a Tableau kind of business dashboard where the CEO of the company, he knows like, okay, what are the different operations, what are the company's current status of the profitability, what is the company's current status of the customer experience, CSAT, which is called as customer satisfaction survey, and the company's overall, what is the manufacturing currently going on, what is the inventories are there. So it gives a like a bird eye view, maybe at a 30,000 feet helicopter view, and hence the like he's completely aware about what is happening and how the company and what is the next strategy which we needs to be taken out. So Internet of Things, cyber physical systems communicate and cooperate with each other and human in real time. So it is like a collaboration of human and the computer. So it's like together. I mean, it's a joint work. It is not like computer is replacing human or human is replacing computer. No, it is like a collaborative and coexistence. And Internet of Services, both internal and cross organization services are offered and utilized by the participant in the value chain. So ultimately, why all these are being done to create the more value for the customers, or more value for the all stakeholders who are involved. So build on the digital revolution, ubiquitous internet, small and powerful sensors, artificial intelligence, machine learning, and saving the energy cost and energy efficiency for the system. So now smart manufacturing enterprises or the smart factory, the industrial internet of thing, IOT, which is nothing but like an industrial internet of thing. Vision of the world is one where smart connected assets, the things. Assets means like things. Things means like individual node or the device. I mean, which could be the in another way, operate as part of the larger system. So if I see factory, maybe having a hundreds or thousands of IoT nodes where, and maybe different gateways, maybe different the computing, but the cloud, it is like maybe Amazon web server or AWS or Azure or Google Cloud, whichever is, I mean, as per the company policy. And there are different types of cloud, like private cloud, public cloud, or there is a hybrid also cloud. So whichever is like suiting to the company's policy and the kind of network system support. So those are chosen, but the confidentiality of data, let's say, if there is a defense organization who is running the smart factory, maybe they will not go for a public cloud. They will go for a private cloud because their security and the kind of threat from the enemies, where the cyber security threats could be higher. So they will go for a private cloud so that data is not in the public domain. Whereas maybe the small companies or something, they may use a public cloud because there are like the data are known in public domain. There is nothing confidentiality kind of thing. So it's a more of an open kind of thing. So it depends on like which company, what organization, what is their philosophy, and that helps to decide them manufacturing enterprise softwares or kind of solutions. The thing possesses various level of intelligent functionality ranging from simple sensing, actuating to control, optimization, and full autonomous operations. The smart manufacturing enterprise is made up of the smart machines. So every machine has to be smart because there is a operational efficiency or which has to be taken care, and every machine idling time also has to be very, very minimal. The plants and the operation, all of which have higher level of intelligence embedded at the core. The linked systems are based on open and standard internet and cloud technologies that enable secure access to device and information. This allows the big data to be processed with the new advanced analytics tools and for mobile technologies to drive the greater business value. In this turn, enables improvement to the efficiency and the profitability, increased cybersecurity and innovation, and the better management of safety, performance, and with reduced carbon dioxide emission impact. As you are all aware, now the sustainability and the green footprint is very key, and that is where every company is working how they can contribute to the COP26, which is a UN mission to reduce the carbon footprint, so that the global temperature, which is increasing by 1.5 degree, needs to be reduced. And there is a mission which most of companies has taken, and few companies are leading. And so the leaders are always makes the roadmap for the other companies to follow. And that is where Schneider has taken a very big lead in the sustainability and carbon footprint COP26 commitment. So smart manufacturing enterprise, while the long-term impact of IIoT is at a time difficult to predict, the three distinct operational environment will set the stage for the smart manufacturing enterprise to emerge. Smart enterprise control. So IIoT technologies will enable the tight integration of smart connected machines and smart connected manufacturing assets with wider enterprise. This will facilitate more flexible and efficient, and hence introduction definition smart manufacturing enterprise. The industrial Internet of Things and evolution to smart manufacturing enterprise profitable manufacturing. Smart enterprise control can be viewed as mid to long-term trend, and it is complex to implement and will require the creation of new standard to enable the convergence of the IT and OT. IT is like information technology and OT is operational technologies. So there has to be a concurrence or there is convergence of the IT and OT system to achieve the Industry 4.0. The asset performance management, deployment of the cost-effective wireless sensor, easy cloud connectivity, including wireless wide area network and data analytics will improve the asset performance. These tools allow data to be easily gathered from the field and converted into actionable information in real time. This will result in better business decision and forward-looking decision-making process. Augmented operators. So future employees will use mobile device, or they are already using data analytics, augmented reality, and transparent connectivity to increase productivity. As fewer skilled workers are left behind to main core operations due to a rapid increase in the baby boomer retirement, younger replacement, and plant workers will need information at their fingertips. So that information will be delivered in a real-time format. It is already delivered, that is familiar to them. Thus, the plant evolves to be more user-centric and less machine-centric. While these three areas are closely related and shared mainly interdependencies, they also have differences. For example, the time scale on which they can be implemented and kind of autonomous market segment that they address are the same, not the same. There are two other areas, collaborative robotics and 3D printing, which is also already implemented in smart factory. And that is going to, that is the making huge impact on the productivity, where the, the unsafe or hazard operations, let's say in a car manufacturing plant, you have a painting, and which is like, human has a, health hazard, because painting human can smoke in, and it can create a lot of health hazards to them. So those operations are being, done by robots, so that there is no exposure of human to such unhazard and unhealthy environment which is there. So like that in various other plants also, like where, acid or plating kind of processes, where a lot of smokes which comes, or maybe even soldering of electronic PCBA, where, smokes are there. So there are a lot of technology and automation has been deployed, and that is making the Industry 4.0 more and more acceptable and sustainable. So smart industry, if you see smart steps, technology, processes, so decentralized decision, virtualization, because everything is visible on your mobile app or your desktop. Communication, interconnectivity, smart manufacturing, innovation and reimagination. So AR, VR, analytics, mobility, cloud, so all these are there. So maybe I can skip the theory and I can go to the smart plant visit also, if that is fine, or maybe I will take maybe a couple of slides and then I will jump to the the virtual plant too. So smart industry levers and value drivers. So if you see like resource and processes, productivity increase of 3 to 5%, because smart energy consumption, intelligent lots, real-time yield optimization. So that is the thing. Smart the asset utilization, 30 to 50% reduction of our total machine downtime. Because most of time, if critical machine in the plant is down, and it can impact the productivity. Hence, the asset utilization is a very key, and the machine flexibility. If one machine is down, there is another machine which can be made operational, or there is a like different kind of SIL level which can be implemented, safety integrity levels, so that redundancy is there, and hence the production is always on as per the plan. Then labor, the 45 to 55% increased productivity in technical professions through automation of knowledge work. So human robot collaboration is the classical example where productivity can increase 45 to 55%. Digital performance management, automation of knowledge work. The next is inventories. Cost of inventories holding decreased by 20 to 50%. Let's say you buy when there is a actual need, and there is a idling time of the material is almost nil. That is like just in time. But post COVID also there was supply chain disruptions. So there is a now balancing act also is being done, and that is where the now sourcing also is based on the artificial intelligence, and it is based on the like kind of a lot of research, and that data is being used. Earlier it was just like by ordered by phone or just by purchase order, or it was like more of that way. But now it is becoming more and more smart, and the sources are also being and multiple alternatives are also being developed. Then quality, cost for quality reduced by 10 to 20%. Statistical process control, advanced process control, digital quality management, and there is a digital dashboard. Quality dashboard also is part of it, and hence the feedback can be given to the other functions immediately. I mean, there is no latency, or there is no and it's a data-driven decisions. Supply and demand matching, because forecasting of the demand accuracy has increased to 85% post industry 4.0 implementation. So data-driven demand prediction, data-driven design to value, and then time to market, 20 to 50% reduction in the time to market. Customer co-creation, open innovation, concurrent engineering, rapid experimentation and simulation. Then there is a service and after sales, because customer experience, like if there is a one product sold, and after that how companies are dealing with the customer issues or customer feedbacks. So if there is a progressive company which is truly industry 4.0 leader, they will have all the systems and processes in place to take the customer feedbacks, to take the customer inputs, and to address the specific customer needs and the issues if there is any, in a very, very agile way. And that is where agility into action is the really key for industry 4.0. So now leveraging industry 4.0 challenges and opportunities is like different kind of organization can drive both revenue and margin by leveraging industry 4.0. And companies who are already implemented industry 4.0, who are leader in and they have increased their profitability, and they have increased their competitiveness by a leap bound. I mean, compared to people who has not implemented industry 4.0. And the transformation opportunity, both business models as well as the business process. And that is where, this business model is like totally changed with compared to the previous, where the industry 3.0 implementation. And digital maturity, digital intensity and transformation management and enablement of new skills, fundamentals, digital niche to have skills. So that's the, I think, key. And if you see like industry 4.0, is like digitization and integration of vertical and horizontal value chains. Then there is a digitization of product, services and offering, and then digital business models and customer access. So data and analytics are as a core capability for industry 4.0. So mobile device, IoT platform, location detection technologies, advanced human interfaces, authentication and fraud detection, 3D printing, smart sensors, big data analytics and advanced algorithms, multi-level customer interactions and customer profiling, augmented reality and wearables, cloud computing. So this is a kind of complete industry 4.0, which offers the challenges, and hence the challenges are turned into opportunities to create the business value and be more and more competitive. So smart industry ecosystem, so digitization is the backbone of it. And then smart sensors are backbone to computerization, connectivity, so that we can see, like, seeing what is happening, why it is happening, understanding, visibility, then transparency, why it is happening. So transparency is the key, and Industry 4.0 brings the transparency. Then predictive capability, what will happen, being prepared. So there is a proactive planning of what is going to happen, and there is a already plan and de-risking it. So hence the risk is very minimized. How can an autonomous response be achieved? Optimizing. So that is the adaptability. So that is the industry productivity and profits. So part manufacturers, quality. If you see here, like the continuous the process is like maintenance team being able to predict and prevent failures. Then continuous process, adherence to process parameters. Then product companies having right materials at right time for assembly, just in time concept. Then high volume asset optimization and efficiency. If there is a like high end equipment or high cost equipment, then that utility has to be ensured like it is always 100% utilized, so that the idling time is zero for that high volume, high capacity or high cost equipment. Part manufacturers quality and productivity is equivalent to profits. So now is Industry 4.0 smart industry is like stronger customer centricity, which comes from agility, then innovation, new marketing and business models. So that is developed by innovation. And then there is a more efficient production processes, which is efficiency. And then value chain transformation through network processing and objects. So that's the, I think, Industry 4.0 drivers. So building blocks of Industry 4.0, if you see like autonomous robots, then big data analytics, augmented reality, simulation, horizontal and vertical system integration, industrial Internet of Things, cybersecurity, and additive management. So digital enterprise, entire value chain is digitized and integrated. So digital world and real world. So digital twin, I think you might have heard about the concept called digital twin. So digital twin is nothing but a physical asset or physical system or physical product. There is a equivalent digital, modeling is created. So if let's say some company want to find out how my customer install the product or what kind of issues they face at the time of installation. So there is a like equivalent digital experience is created, and it is being used as a trainer. Like you might have seen the aircraft simulator or pilot flight simulator basically. So while pilots are being trained, so there is a like they before going for an actual flight, they go through the flight simulator and they try to gain that experience, and then they get into the actual flying the plane. So similar way, digital twin is also helpful to create the experience for the the untrained manpower, or maybe the sometimes customers we can make the customer also maybe aware about what kind of cares or precautions they need to take care. And those things are all, and then even suppliers also we need to train. Then whatever product life cycle management, whatever manufacturing execution systems, totally integrated automation. So entire thing can be viewed and optimized basically based on the digital twin concept, and that is where the digital enterprise which has come in. So potential application: robot assisted production, predictive maintenance, additive manufacturing of the complex parts, machine as a service, big data drive, quality controls, production line simulation, smart supply network. So industrial Internet of Things, IIoT, I think as we had already used this term, and this has been because IoT is a Internet of Things, but industrial environments are more harsh, and they require more immunity from various kind of industrial noises like EMI, and like kind of various unpredictable noises of motor or machines operated. So they should not have and it requires more immunity in terms of temperature performances. So industrial grade and consumer grades, like IoT mostly consumer grades product, but IIoT is specifically for the industry or industrial environment. So in that, it is presented as a revolution that is changing the face of industry in a profound manner. In reality, it is a evolution that has its origin in technologies and functionalities developed by visionary automation suppliers more than 15 to 20 years ago. As the necessary global standards mature, it may take another 10, 15 years to realize the full potential of IoT. Still, I think we are already very advanced stage in leveraging the benefit of IIoT. Over this period of time and the changes of the industry will be reaching, and the good news is that end users and machine builders can now leverage their existing investment in technology and people while taking advantage of the available new IIoT technologies. So it's like a wrap and reuse approach rather than a rip and replace approach, and will enable greater business control. In addition, this measured approach will drive the evolution towards a smart manufacturing enterprise that is more efficient, safer, and sustainable. So if I see IoT ecosystem and value chain, so IoT is like end-to-end ecosystem, sensor to cloud to big data analytics, maximizing the business value. And this is where the business model evolvement happens. So the connect everything from the soft floor to the top floor. So that is a kind of connect concept. Then collect, capture critical data at every level from sensor to the cloud. Sorry. So the analyze, convert the data into many meaningful analytics. So that is kind of analyze, and then to take the action. Because without action, if you have a vision but you don't take any action, it will not give you the result. To get the result, you need to take the action and drive the action through the real-time information and business logic. So it is not just going by perception, or it is not just going by the hunch. It goes with the real data which is on the table, and those data are translated into the real-time actions with the measurable. Because in the industry, everything is being measured, and if measurement is not giving the results, then the strategy has to be changed or readapted. So that is closing the loop. So this will be like a PDCA, Plan, Do, Check, Act. If you see the Japanese philosophy of Plan, Do, Check, Act, PDCA, till you achieve the desired outcome, you have to run this cycle for multiple times, maybe in an iterative way, 1, 2, 3, 4 times to maybe 0 to 80% you can get maybe in the first trial itself, but 80 to 90 it will require maybe little more trials. But from 95 to 100 you will have even more and more tougher challenges, because 95 to 100 getting is like will require more investment, more kind of efforts, more intelligence, more wisdom, and hence it is more challenging to achieve. Maybe 3 sigma quality or 4 sigma quality anybody can achieve with the lesser effort, but 4 to 5 sigma is a challenge. 5 to 6 sigma even have a higher and higher challenge and higher investment. So those are the companies who are pioneer or leader in the industry segment. They will be able to achieve 6 sigma, but not the every normal company. And IoT actionables will define the success. So that's the kind of IoT ecosystem and value chain. So IoT chain is a network of network, a world wide web, which is like a WWW. And you can see the complete visualization of like human and the sensors, the sensors and the actuators, and that goes to the gateway over the private network, then a gateway to the cloud, or the storage is like public or private or hybrid, whatever is public cloud, private cloud, or hybrid cloud. Then analytics and with virtualization software. Then data ingress, the cloud, in the cloud, like there is a storage, there is a analytics, there is a data ingress. Then from the smartphone, which is like towards the control, insight, data is like observation, and then from observation you can derive the insights, and insight can lead to a control. So hence this is a kind of closed loop system where you have because open loop system you have no clue about whether it has improved or not and what needs to be changed. So closed loop system is there, and hence the feedback from the smartphone and over the direct wireless or like that goes to sensors and actuators, and that's the kind of IoT chain, which is network of network. So smart factory system architecture, if you see ERP, there is a PLM, product lifecycle management. Then IoT next generation system interfacing with legacy, rep and reuse. Then you have SCM, supply chain management. Then you have CRM, customer relationship management. You have sensors and actuators, controls. You have MOM and MES. So asset performance management, like how you are able to optimize your asset, cloud ready for non-mission critical apps. So asset performance accelerates the adoption of new performance management applications leveraging big data and analytics and cost-effective wireless mediums. So here you can see IIoT next generation systems. So performance management, real-time decision support, energy management, the plant energy consumption, motor energy consumption, individual machine, OEE, and then condition monitoring, remote monitoring. So you can see the cloud-based apps, wireless connectivity, LP WAN, low power WAN, or IoT sensors. Then you have the sensors and actuators as layer 1. Layer 2 is control, discrete or hybrid or continuous. Then layer 3 is manufacturing operation management, mission critical real-time hardwired connectivity, and L4 is like ERP, which is at the cloud level or kind of it's like to optimize the asset performance. So augmented operator, if you see L1, L2, L3. So L1 is like sensors and actuators, control, then manufacturing operations, and L4 is like ERP, layer 4 basically. So L1 is like lowest layer, which is like sensor or actuator layer. Then control is like, gateway or maybe kind of, you have the edge kind of devices, which is there at the L2, and manufacturing operation management is like analytics and software that again comes from the like your mobile app or your kind of tablet or PC, or L4 is like your ERP, so which is like a complete data management. So worker competency is smart industry, because worker has to also upgrade his skill to be compatible with the smart factory concept or smart industry concept. So that's the kind of thing which is really required. And then you can see the mobile softwares, web and internet, embedded controls. So all these are the part of enablement of the workers, and worker needs to go through the trainings. Worker needs to go through the various kind of how to leverage, how to use them, and in case there is issues in the some systems, or how to debug, repair, maybe have a redundancy so that there is downtime is zero. Then this is Industry 4.0 performance dashboards. So you can see the various kind of dials, dashboards, various kind of Gantt charts, various kind of pie charts, and various kind of the kind of data analysis tools. I mean, and quality analytics tool. So like total productivity management track. You can see the TPM. Part A, plant B, or if there are multiple plants, let's say if some company has, let's say, hundreds of plants over the world, then the CEO of the company may have all the plants visibility on his desktop or on his system, so he can view like all the plants are running as per the planned capacity, or there is some downfall, or there is some issues, or there are some problems like there are sometimes strikes or labor union problems, so the productivity is not there. So maybe there can be a automation mix can be increased for the product which is high volume, and product for low volume maybe okay. I mean, we can have that mix and match model, but we can have the how to overcome those kind of challenges. So all those are part of the Industry 4.0 performance dashboards. So now if you see the topology of Industry 4.0, so you can see the manual, sensor, programmable logic controller, PLCs, then CNC machine, then robots, then your quality control systems through the softwares on premise, and then there is something on the cloud. So acquire the data by sensors, PLCs, or maybe give control over by the PLCs. Then analytics engines, so third-party snap-ins like wireless messaging, knowledge systems, quality systems. So these are all alerts or maybe escalations. If some things are not happening as per the plan or time, then there has to be an escalation to the next level of management, to the top level of the management. So soft floor to top floor is the concept for industry or smart factory. And then there is an integration with respect to ERP, enterprise resource planning. Then there is a kind of scheduling which is there, or the planning for everyday operations. Then corporate systems optimization also is part of it. And then analytics engine, that is the brain of it and wisdom of it actually to optimize that. Now digitization Industry 4.0. So digital technologies that physical world, so augmented reality, blockchain technology, big data analytics. So I think you have some session on blockchain, maybe in the and the Internet of Things, then rapid prototyping. So these are all like flexibility and fast innovations, distributed and aggregated system analytics. So device management, app store, edge devices, then edge apps, in-machine field level, edge computing, cloud computing. So now smart transition to smart manufacturing. So the nurture manufacturing excellence, establish a manufacturing system that can benefit from the digitization, foster innovation, create functional and end-to-end innovation ecosystems, facilitate investment, modern industrial policy that attracts and de-risk investment. So now Industry 4.0 is driven by the need of the customer. So we can see here, customer needs new business models, speed, flexibility, quality, efficiency, and security. So if you are ordering a mobile and if somebody says you have to wait for 3 months to get a mobile, will you be the happy customer? No, you will say I have ordered and I need next 1 hour it should be on my desk. So that is where the Amazon has created that business value. I mean, and they had put that business model. So future of automation, from automated towards autonomous systems. So there is a that is where the Industry 4.0 is like autonomous system. So now enabling technology is like connectivity and edge devices. Device becomes intelligent and connected. Then data analytics, artificial intelligence, making automated decisions. Then simulation and digital twin, as I already explained, like digital twin is like physical simulation in the digital world of the physical things. Expanding the digital twin, then cybersecurity, enabling digitization, and where the data security and safety, and there is a GDPR kind of compliance, which is there. So Industry 4.0, smart factory or smart industry. So 4.0, 4 steps towards vertical value chain, company sales, product R&D, planning, and then there is a service, IT shared services, finance, tax, legal, data acquisition, analytics and alert, planning. So now logistic, manufacturing, purchasing. And now there is a data acquisition, analytics and alert, then feedback and workflows, then integrated enterprises. So now you can see horizontal value chain, suppliers, company, customers. So network of suppliers, because every company will have a network of suppliers or base of suppliers. Manufacturing is like internal to company, and then network of the customers, because customer base also, because customers are the people who order, and company manufacture, and so maybe take the goods from suppliers, some in-house manufacturing, and then finally integrate, test, and ship to the customer, so that customer experience and the reliability of the product is ensured. So now assembly line layout, you can see the different kind of assembly line layout for Industry 4.0. So now you can see the kind of IoT network, I mean the press line. Let's say the press line is the, maybe I will use the, I think pointer, laser pointer. So here, let's say this is a press line. This is the IoT network. So there are, you can see 1, 2, 3, 4, 5, 6 kind of, the workstations. And you can see the truck here also. So now if you see like how the entire things works here, I mean, so here you can see the one computer and standalone machine SME, and then high-tech machine line, this is another line, and then this assembly conveyor is there, then track and trace kind of supervisor, line supervisor, or whoever is there. I mean, then virtual factory and end-on. So there is if any escalation or if there is any end-on, means there is a kind of complaint from the any of the operator or in the assembly line has been raised, so that red flag raised, let's say. So that will come to him, and then it will analyze and immediately give a clearance or green, So real-time operative energy efficiency, and then the productivity analysis, assembly and conveyor monitoring. Then here you can see office and the maintenance kind of, and then the stores are there. So here, like in to out, you can see like online inspection and Foka Yoka kind of setup is here. So it flows like, the assembly flows like this, and then this is another assembly line. So, and then finally it goes to the truck where it is being dispatched. So now, if you see industry analytics driven, so analytics driven is smart manufacturing, financial impact, production, service, downtime, benchmark, preventive and predictive maintenance, utility and consumables, variables, variance, operator performance, machine capacity, work in WIP is like work in progress kind of inventory. I mean, WIP inventory is there, and then historical analysis and data mining. So plant floor scoreboards motivate your operations to meet and exceed goals. After all, everyone likes to win. Now here, strategic analytics, tactical reports, and operational scoreboards. So you have a different. I mean, you cannot have operational and strategic as a same. Strategy is like a very long-term focus towards the transformation of the business, while operation is like day-to-day work. I mean, every day whether the goal has been achieved or not. But operator may not have the strategic view of the company, but that maybe there is a separate team who works on that in background with all data analytics to derive the next level of strategy for the business transformation. And tactical is like maybe a like monthly or quarterly or yearly kind of what was the revenue, what was the number of quantities sold, what were the typical customer complaints or issues, how we are addressing them. So all those are part of this. So total productivity management track and implementation use cases. So total productivity management is a concept which is being used in Industry 4.0 and where to deliver the customer value. So you can see here like the maintenance actions, equipment to be monitored. There is a thing, and then there is a like a network which is there. Then secure communication, post processing, master node, industrial sensors, wired connectivity, MCU, wireless connectivity, and node is there. Then here, if you see AC energy meter, so energy meter value, then these are the current sensors, CTs, and then there is a value which is taken. Then over the communication, the value is taken like the machine, like RS485 cable. So RS485 communication happens with the two different devices. Then there is a turbine which is there. I mean, and then finally the CPU, and then this is a like kind of. So this is a, like a kind of TPM track server which takes the data and monitors it. So now here you can see artificial intelligence in manufacturing. So that's a kind of neural network or machine learning model algorithm. So there is a lot of data you can have this smartness built into kind of software and analytics tool, and then maybe you can individually operate the machine with that concept, and that to bring the highest level of productivity. So factory of the future. So this is machines self-optimize their parameters on basis of material input and process parameters. No manual interventions. Then there is a virtual agent verbally provides operational operators with information from IT system upon request. And then there is a kind of automated guided vehicles, carry parts, detect obstacles, and adjust their routes. So there is no trolley, manual driven trolleys and those kind of things. Then AI system develop new product based on generative design principles. So like if what kind of typical production issues, what are customer compliance issues, so design people also get the input data from all of them as a summary, and then design people next generation product, they can proactively take care of all those issues so that the next customer experience is far and far superior and rich. Robots use image recognition to automatically adapt to the changing location of the part. Then AI system detect quality defects and through image recognition. So quality and defect reduction can be done automatic. Then AI system accurately predict future demand for product by learning from the partners, patterns in the demand and environmental area. Then assistant system suggests solution to incidents based on the earlier failure reports. And then AI system predict quality issues by analyzing and learning from the quality and process data. AI system predict maintenance needs by the identifying failure patterns. So proactively it can give that alarm and warning, and it can even like there is no production down, and other alternative machine is already put it there, taking into account material outflows, inflows, inventory levels, etc., etc. And so this is kind of industry 4.0 factory. And then you can see like manufacturing sector, AI and advanced analytics is at the core of the smart manufacturing. And you can see predictive maintenance, demand forecasting. So I think these we had already discussed in digital twin, factory operations, human robotics collaborative ecosystem. So AI and analytics strategy, understand your starting position, understand the consumer expectations, and then review your current maturity and identify areas. So this is a kind of business model how we can develop. Find a champion. We have to find a champion, identify the right leader to sponsor innovation and change, because chief operating officer, chief financial officer of company, or chief data officer of the company can help minimize internal resistance, because there will be a lot of internal resistance of the people who are already working with, and they are very comfortable with the existing things. So they may oppose, they may put a resistance. So to overcome that resistance, maybe chief operating officer or chief financial officer or chief digital officer of the company can really have make that smooth, and like run a small pilot, demonstrate the benefits, define your organization as a start to implement the changes, define your strategy, like determine the larger target maturity levels and the vision that best supports your business strategy. Then develop the appropriate roadmap. I mean, because there has to be a visibility and time-bound action, and where the benefits are measurable. Actually, settle to the like necessary implementation steps and work them into detailed roadmap. Then deploy the small pilots, because seeing is believing. I mean, and sometimes we may not have enough foresight or enough visibility till we try and experiment. Actually, so this is kind of a experimentation. So it should not be deployed across, but you can take a one high impact area, or where the low investment area, but the results are very high, output is very high. So those kind of you can prioritize and select and deploy there, see the benefit, and half of your resistance will automatically die down by seeing this output. So people who are earlier, like not in favor of this change, now 50% people will automatically come in favor of this change, because they had seen the benefit, they had seen the impact on the output and productivity, and they will see the kind of quality of their work also. It has helped, because automation and digitization has helped, and segmented rollout and then capability development. So then it can be horizontally deployed, maybe at the different across the organization. But first is like having a successful pilot to demonstrate the benefits and showcase the advantages. So this is kind of business model development which is being done. So today's manufacturing scenario, like this is a car manufacturing plant, where we can say mass production is based on one simple rule: the more things you make, the lower cost of each of those things. This equation is literally pushed to the extreme limits. Henry Ford perfected the model of mass production, and by 1950, he has reduced the time it took to build an automobile by 90%. So you can see the 90% time reduction is a great advantage of the industry process. And the famous statement, mass production is not the end of this story, but rather just a stop along the way to something completely different. And what is, if a technology came along with that, could be turn everything upside. So 3D printing, you might have already heard about rapid prototypes. Like we a lot of times new concept, if you want to prove, if you want to make with the kind of better visibility, better anticipation, you can always do that 3D printing, and it is being used by industry widely. And then World Growth Initiative, Smart Industry. So these are the pioneer, countries which has taken the benefit of Industry 4.0. You can see like largely Europe, US, even in India and China, who are becoming more and more industrialized, and making India concept, and now even semiconductor industry also is taking the advantage of all these smart industry. So if you see now the changing precision technology, smartphone manufacturing, number of employees earlier was 650, after that it is just 60. Number of robots 0 earlier, now it is 65 robots. Like I will take one example of Foxconn, like which is making the iPhone in the like China and now in India also. So there is a lot of advantage because earlier there used to be a lot of strikes and something. So now that has been very optimized, and it has to work. I mean, to benefit of the society also, but at the same time it has to ensure it is survive its own business also. Because if it just get into social security, then business itself will not survive. So first business has to survive and then work for society also. So it's like in aeroplane when you are traveling. So first is like first save yourself and then help others. If you cannot save yourself, then you are not in capacity to help others. So that's the kind of philosophy which is I mean there. And defects earlier was 25%. Now it is like just below 5%. 80% reduction in the defect. Production per person 8,000 units, and now it is 21,000 or even more than that. I mean, millions of units. So IoT AI is revolutionizing the smart industry. So technology, robotics, 3D printing, big data analytics, process constant communication, data exchange between components, then decentralizing decision making, then smart transport, people, increase efficiency, reduction in labor per unit, skill development, upskilling, reskilling. Sometimes reskilling is also required. I mean, if somebody is not, reskilling, then probably he will become redundant and outdated. Actually. So it is required to be reskilling at a time. So digital factory or smart factory, nearly half of the companies say they don't have the digital skill they need. By Jeremy Goldman. After all, in just one decade, the concept of digital has changed from a niche skill set to something that is mandatory for virtually all blue chip companies. Employees' digital IQ have become critical. So if digital IQ of the employee is lower, then it means it is not suitable for the smart factory. So digital IQ has to be increased as a training part of it. So key component of the current value chain, you can see the supplier, tier N supplier to tier 1, raw material located strategically to benefit from the scale, tier 1 suppliers, manufacturers and supplier subsystem to OEMs, located close to enabling just in time. Like Maruti Udyog, you can see the concept of like just in time, or maybe there is a like automotive hub or such kind of things, or electronic manufacturing kind of concept. So manufacturer high capex involved, covers a larger geographical area than logistic transport from OEM to distributor dealers, then the channel member, customer facing, handling financing and insurance needs, some marketing efforts, after sales service, post sale customer service, on road repair and maintenance services. So integrated re-engineering value chain, advanced manufacturing system, sensor traceability, predictability, 3D printing, scrap elimination, customization, cloud computing, big data, cybersecurity, robotics, autonomy, productivity. And here you can see tier N suppliers. So that is like tier 1 supplier, fully integrated supply chain, perfect coordination, manufacturer, alternative resources, wind, solar, nuclear for power or whatever kind of like earlier they might be depending on single source of supply, logistic optimization, channel member, after sales service. So top 10 skills to be relevant in critical problem solving, critical thinking, creativity. Now, I mean, it is like 2023. People management, coordinating with others, emotional intelligence, judgment and decision making, service orientation, negotiation, cognitive flexibility. If somebody is too rigid and he is not adaptable to the new digital technology and industry 4.0 practices, maybe he can be a lot longer a problem in the company. The resource can be complex problem solving. I mean, so some are there, but if you see the kind of cognitive flexibility and kind of service orientation, emotional intelligence, so these are the all new areas, I mean, which has come into for a smart industry skills. So economy it impacts, individual it impacts, society it impacts, national and global level it impacts, business it impacts. So industrial Internet of Things example from GE predicts the operating system for the industrial internet is powering digital business industries business that drives the global economy by connecting industrial equipment, analyzing data and delivering real-time insight. Predict based apps are unleashing new levels of performance of both GE and non-GE assets. So robotics working in Amazon. I mean, I don't have latest data, but till 2016 data I have here. So you can see that like 2013, almost more robots than 2014, 15, 16, you can see. And now it may be millions of robots are working. And then impact, I think we had already discussed. So these are references which I had taken. And now, we have an embedded design and development group, which we work in maybe IoT based industrial product as well as the switch gear and electrical product. So thank you for your patience hearing. And now I will have kind of virtual smart factory too. So as you all are aware, like there is a PS Day 2023, and April month is the PS month. And so, however, I am 5-6 days delayed here, but still I thought this is like part of my PS Day kind of. So now I'll maybe share the industrial smart factory. So please give me a few seconds. I will stop presenting here. And so I will share my screen. Just a minute. Hope you are able to see my screen.
Yes, sir, it's visible.
Yes, sir, it's visible.
Yeah.
Sir, there is no audio.
Oh, audio is not there?
No.
Just a minute. I think then let me include the audio. Just a minute. I think then I have to start from beginning. I just thought. Just a minute. Maybe like there is a how to include the audio. I mean.
Sir, either you present your complete screen.
Okay. So if I put a complete screen, then audio will be audible, right?
Yes,
Okay.
yes.
Okay.
Also, yours should not be on mute. Your mic
Okay.
should not be on mute.
Oh, my mic should not be on mute. No, my mic is, I think, on actually.
Okay.
I can see it is on.
Okay, just check if you share your complete screen.
Yeah, sure. I'll just try that. I hope now it is visible. Screen. Hello.
Yes, sir. Screen is visible.
Now audio is audible or still not?
So just play it.
It's audible.
No, sir.
It's not audible. Okay, just a minute. Let me. Okay, let me just check in my settings. So maybe I will, if the audio is not audible, maybe I will keep on talking in between. But I don't know why the audio is a challenge. I had shared my full screen. Maybe let me take my headphone out and let me see if it.
Yes, sir. Please remove your headphone.
Yeah, now it is audible.
So just remove your headphones. You are using headphones. That's why it's audible to you only.
Now it is audible. I had removed my headphone. Now it is audible.
Still not audible, sir.
It's still not audible. Okay. So I think what is the issue? Maybe then I'll share the recording. I mean, I have that recording also. Maybe I'll share the link and maybe then like the participant can go through it
Yes, sir.
offline.
Yes, sir.
Yeah, if we have that issue. So yeah. So maybe now I will again go back to the then presentation. So I think largely these were like all. So I'll share the recording, and I think with that I should be able to there is already I have a recording and which covers, but it will take maybe 1.5 hours if people who are interested. So I will share with you, and then you can circulate to your like audience, so they can go through it and like they can understand that smart factory, how real time it is implemented, and like what are the all components which is part of it actually. Hello.
Yes, sir.
Yeah. So I think that's the kind of because I thought the audio was of almost the video was of almost half an hour. So since I think the audio there is some challenge, so maybe I'll share the link of
Yes, sir. In
yeah.
chat as well, you can share the link if you want.
Uh, yeah.
Maybe afterwards, if you.
Yeah, afterwards I'll, because I have a almost 2 hour kind of one session
Yes,
which
sir.
I had
Yes, sir.
I
During
had
evening
delivered.
session, yes, you can share.
Yeah, so I had taken one session for USA. There was a participant for IEEE from USA. So I had taken a one session, and there is a recording there. So I will share
Okay.
the link of that recording, which has I think all these
All right, sir.
yeah. So with that, I think I would maybe I'm open for the any question and answer if any participant has.
Any questions, anyone? You can type in the chat box if any question, or you can unmute. I guess no questions are there. So Chaudhary sir,
Yes, sir. Yes, ma'am.
so session is over.
Yes. So, thank you very much. BL Bishnoi sir, thank you very much for your technical insights regarding Industry 4.0, its challenges, opportunities, how to leverage the best of the outputs from the workers, then how the smart industry is moving towards the ecosystem, what are the profits regarding it to be considered, how the digital enterprise will work, how ecosystem and its flow will be comes into picture while designing the system architecture of the industry 4.0. So thank you very much, sir. Thanks for being with us and enlighten us with the various technical deep insights from your side. Thank you very much, sir.
So, sir will
Sure.
join us again. I
So all the participants who, yes, we will join us again at 1:30
we can break now.
for the, yes, we will have a break now. So thank you all.
Yeah, thank you very much.
Yes, yes, sir. Thank you, Bishnoi, sir. Thank you very much.
And in case anybody has a question, I'll put my email ID. So like if anyone even get a question afterwards, so they can also
Group photo.
they can send me an email or they can
Yes, sir. Sure.
Yes, sir. Yes, sir. Sure.
yeah.
Yes.
So this is my mail ID which I had just typed in. So anyone has any question, please do drop me an email, and I'll be more than happy to resolve your query or any question you have.
Yes, sir.
Yeah, sure.
So can I request all to please make your video on so that we will have a group photo. All please make your video on just for 2 minutes. We will have a group photo. Ready, sir? Yes, all please join. One more, huh, sir? Yes, ready? One more, please. Okay, it's done. Thank you very much.
Yeah, thank you very much.
Yeah, yes, sir. Thanks. Yeah.